Okay, today we are designing a disc type oil skimmer. So let's get started. I'm designing this oil skimmer in Fusion. This is not a paper motion for Fusion. Fusion is a great 3D modeling software. It has this great feature where you can pull in parts from McMaster-Carr's website. I'm pulling in this gear motor. The gear motor is sort of the heart of this disc type oil skimmer. These gear motors are nice because they spin nice and slowly, which is what you need with an oil skimmer. See, it's got a little cooling fan there to keep the electric motor cool. And I'm going to create a sketch on the face of the shaft, and I'm going to build out my disc from there. And the disc needs to be made from a oleophilic or hydrophobic material. And all that means is it repels water, or water won't stick to it, but oil will stick to it.
Wow.
Then I'm also going to create a bushing here using the extrude command. And eventually we'll put a set screw in that bushing that will attach the disc to the shaft. And in the render screen, we can add color, add texture, make things out of metal, etc. Simply drag and drop what you want. Okay, now we're going to work on the frame that the base of this gear motor will bolt to. So in sketch mode, I'm going to create some construction lines. That'll give me a center point where I can drag out a rectangle that I will extrude to make the base plate that the motor will mount to. The frame for this entire assembly is going to be 1/8 inch thick, mild carbon steel. So it can be made out of flat bar, out of 1/8 inch thick sheet metal that you cut out. Could use a plasma cutter or a water jet table, etc. Okay, so I use the same extrude command to make the troughs that the oil will be scraped off into and subsequently run down through a pipe nipple into a 55-gallon drum or a 5-gallon bucket to collect the oil that is skimmed off the surface of a body of water. So I simply make one trough, then I copy it and move it over. So now I got a trough on each side. And then we'll make our squeegees that will squeegee the oil off of the disc. As the disc slowly turns around, oil runs into the troughs, again down the drain into a waiting bucket or drum. Now we're going to go ahead and make our squeegees. Now to make the squeegee on the other side, I'm going to use the mirror command. As you see here, there you go. Woo! Just elongating the frame with the extrude command. And then I want to bridge that gap between the two pieces of flat bar with another piece of flat bar, like so. Now I need to finish up designing and fabricating the back end of the collection trough. And again, we'll do a sketch. And then after the sketch, we'll use the extrusion command. And these troughs, you'll note, are made out of small C-channel or U-channel. You can buy that kind of material, or you can make it out of 2 pieces of angle iron welded together, even all flat bar welded together. Now we will go ahead and bring in a 1-inch national pipe thread, pipe nipple, threads on one side, but not on the other side. And we'll punch a hole through the trough, and we'll weld the nipple to the bottom of the trough. And that'll be our drain. Woo! And that's where the collected oil would drain into a bucket or a 55-gallon drum. So a couple things I want to do. I want to make these squeegees a little bit longer, and then I want to attach some flat bar mounting plates that the squeegees will screw to or attach with, if you will. And when you're iterating a 3D model, if you just simply click on the little eyeball symbol on the left-hand side over there, you can temporarily hide a body or a component to work on other components, and then click the eyeball again and the component will reappear. And I also want to elongate the back of this trough. And here I'm adding the flat bar that will be welded to the trough on either side, and that is what the squeegees will attach to. Okay, now we will go ahead and create a sketch and create the cover that will cover the motor, and we'll also create a louvered vent so that cooling fan can keep the motor nice and cool. So again, same commands, extrude command, and then I use the shell command to create the box, if you will, or the cavity of the inside of that cover.
Wow.
So I do not need to model each and every louver. I'll simply use the pattern on path command, as you see here, to make my louvers. Now let's bring in a strain relief for the power cord. We'll then create our power cord and then bring in a cord cap, male plug, to complete the electrical. And we'll also bring in a toggle on and off switch. Okay, we're almost done with this project. Need to put a cover plate for the bottom of the motor enclosure here. So again, make another sketch, extrude up an 1/8 inch thick steel plate. I hope this tutorial helps you. Please consider subscribing. It helps this channel move up in the YouTube algorithm so we can help more people with their industrial design and facilities maintenance equipment tasks. So here I'm adding text, and then I'm going to extrude the text slightly just to give it a little bit more depth so you can see it better. And then we'll add some color in the render screen to make it pop. And one of the last things I'm doing here is adding the mounting screws that attach the squeegees to the body of the oil skimmer, or the side of the trough, if you will, on each side. And again, I bring in one and just do a copy of the body, and then copy 2 bodies to do the screws on the other side. Now I'll go ahead and bring in my set screw that will attach the disc to the motor shaft. So that's going to be our finished project for today. So basically the way these disc skimmers work, they sit atop the tank or whatever body of water or fluid you're trying to skim oil out of. The oil gets stuck to the disc, gets scraped off via the squeegees into the trough, down the drain. Please like, share, subscribe, leave me a comment, and thanks for watching.